This could have been, actually, what I'm about to say here could have been the preview of inverse functions in the first place. Let's look at a bit of history of your learning in math. First, probably the first mathematical operation you learned was adding, and then you learned subtracting, right? And then you might have learned multiplying, and then later you learned dividing. At some point you learned how to square numbers, right? Squaring, like powers, exponents. And then you probably learned square rooting something. You've learned some other operations since then, other functions. You've learned taking the sine of a number, taking the cosine of a number, tangent. And now, well, you've actually learned it already, but you've never graphed it or looked at it as a function. We're going to look at this as a function, cos inverse as a function. You're going to combine some things together that you probably already know then. If you know that sine looks like this, okay? Again, we'll look at technology because that looks horrible.
It's just awful.
It is. It really is. Let's even pause. So there's sine x. If we're going to draw the inverse of that, so this is y equals sine x. Must remember to disable that. That's y equals sine x. If we're going to draw the inverse of that, just think about some of the points involved here and flip them around, right? Instead of this curving over like that, right? Instead of this thing curving over like that, it's actually going to curve up like this, right? Except it would stop at about 3, right? This point right here is going to be this point right here, right? It's going to go up to how much here? It's going to go up to 1, so it's going to be something like that. And then it's going to continue on like that, right? This is going to go like that. And it's going to curve like that. This is going to be, instead of a curve that goes sideways, it's going to be a curve that kind of goes like that. Back to that. How did I get back to drawing here? I thought I was going to use the technology. And then it would be, oh, it's just terrible. I've never claimed to be. Okay, anyways, that's the idea, right? Is this a function, that curve I just drew? Is it a function? No, right? Because anywhere you draw a line, it's going to have far more than one. It's going to have an infinite number of times that it crosses, right? For any one x value, there's lots of different y values. If it's a function, think about how your calculator works. When you put in a number, you want it to give you one number. You don't want your when you say the sine ratio works fine, because when you say 30 degrees, great, here's the value, right, or whatever. When you put in a number, it gives you one value. You don't want it to say 0.5. What number goes with that? If you put in a sine ratio of 0.5 and say, what's the sine inverse of that? You don't want it to say, oh, by the way, it's any one of this list of an infinite number of things, right? You want it to only give you one number for it to be a function, right? You can't say, well, I don't know, it could be any one of these infinite number of things, because it can, right? There's an infinite number of angles that have that as its ratio. If you're using it as a function, you have to limit it here. Since trig functions curve back on themselves like that, the way it's going to be is the sine inverse function is defined to be this piece of this curve here, just that. Okay? So if I go back to this software here, if I'm going to put in now y equals sine inverse, which I'm thinking that, I don't even know how actually arc sine. They don't do the -1 thing there. There's arc sine, a sine on this program. That gives you that little piece of that. That's this part of it flipped over. Okay? That's the reflection of that one piece of that curve. Okay? We could even change this color here so you can see it a bit better. Must not give you choice of color or you'll all want something different. Okay, that's the inverse of that. If I was to graph this, x equals, let's see if this does this, x equals sine y. That's not rating it as that's the inverse of y equals sine x. X equals sine y is the inverse of y equals sine x. But it's not written as a function the way we think of a function. It's written the other way around. It's actually written as x is a function of y, and it doesn't like that on this software. But if it could graph it, what would it have to graph? Then it could graph the whole thing, right? But if we want to write it as a function like g of x, this function of x is arcsine of x, you got to limit it in between there, okay? If we're going to graph like this blue curve here, you can call this blue curve x is the sine function of the y value. That's okay. You can have x as a function of y if you want. But if you want to write y as some function of x, it has to be restricted to certain values. You know that from your calculator. When you use that sine inverse key, it's no matter what you put in here, it's always going to give you an angle between negative 90 and positive 90. When you did trig in grade 11 and 12, when you looked for angles, you had to find the reference angle and use that to find other angles. That's because the calculator only gives you angles between certain values. And then you can use that to find the rest. So that's essentially what you're doing. You're saying, give me the first one, and I'll use it to find other ones. We're going to talk more about inverse trig functions later on in the course when we get to that. But for now, you can realize they are functions. You can graph them. I didn't put a lot to think about in here other than that's what they look like. And the other way of writing them is, which I actually like better, is arcsine. Because then it's clear. We don't have the confusion of what does that -1 mean and things like that. Okay?